Okay, I'm going to pick up in this video right where the last one left off with number 4 on the worksheet. So for number 4, show that two ordered pairs are solutions to the given equation. Okay, so that's step 1. And then once we do that, then we'll use the graph of the 2 points to determine another solution. Okay, so let's start off with these 2 points. So we'll call this point number 1, and let's call this point number 2. So let's make sure they're both solutions. So for point number 1, x is 2 and y is 4. Is that a solution to the equation 2x plus y is equal to 8? Well, we'll replace the x with the number 2, and we'll replace the y with the number 4. So instead of 2 times x, it's 2 times 2, and instead of plus y, it's plus 4. And we get 2 times 2 is 4. 4 plus 4 is 8. We get 8 equals 8. So yes, that first point is a solution. So when x is 2, 1, 2, y is equal to 4, 1, 2, 3, 4. And that gives us this point right here. All right, so when a point or when an ordered pair is coming from an equation or is a solution to an equation, that point is basically a picture of the equation. One point is one answer or one solution. Okay, so let's see if that second point is also a solution. So point number 2. X is equal to 6 and y is equal to negative 4. Okay, so again, we'll start with the same equation. 2x plus y equals 8. And we'll replace the x with the number 6. We'll replace the y with the number negative 4. So 2 times 6 plus a negative 4 equals 8. 2 times 6 is 12. Then plus a negative 4 is minus 4 equals 8. And we get 8 equals 8. So yes, check. Both of these are solutions. So when x is 6, 1, 2, 3, 4, 5, 6, the y value is negative 4. So here is the point 6, comma, negative 4. And this one up here was 2, comma, 4. So once you have 2 points, that defines the line. All right, so we could connect these 2 points, and it actually keeps going in both directions. And so any point on this line is also a solution or is also an answer to that equation, to the equation 2x plus y equals 8. So this point right here, it looks like it's 8 on the y-axis. So that would be the point 0 for x and 8 for y. That's a point on the graph. And this one right here, it looks like when x is 1 and y is 6. That's another possible answer. Any of these points in this one, when x is 3 and y is 2. And so any point on the line is a solution to the equation 2x plus y equals 8. All right, let's move on to number 5. Because in number 5, we're introduced to a really important word, and that word is intercept. In this case, it's the y-intercept, but in general, the word, so let's call this a definition. An intercept is a point or an ordered pair that contains the number 0. And now specifically, since there's two axes, there's the x-axis and there's the y-axis, so we could talk about the x-intercept. And we could talk about the y-intercept. So the x-intercept is a point where y is equal to 0. Because if y is equal to 0, that means the point is on the x-axis. So intercepts are points that contain a 0, and that means they're going to be on either the x-axis or the y-axis. And the y-axis, or sorry, the y-intercept is a point where x is equal to 0. And that's what we're going to use for this problem. Find the y-intercept for the given equations. Okay, so let's start with this one. Y is equal to 1/3 times x plus 9. And since we want the y-intercept, and this is a general rule that always works in any math class. To find the y-intercept, you let x equal 0. So if we plug in a 0 for x, we get y equals 1/3 times 0 plus 9. And 1/3 times 0, that's just 0. So we get y is equal to 9. So by definition, the y-intercept is a point where x is equal to 0. So the y-intercept would be the point 0, 9. Okay, and let's do the same thing for the second one. So for this equation, let's find the y-intercept there. So we have 9x minus 3y is equal to 15. So again, if we want the y-intercept, that is where x is equal to 0. So let's plug in a 0 for that x. So we get 9 times 0 minus 3y equals 15. And 9 times 0 is 0. So we have minus 3y is equal to 15. And we're trying to solve for y, so we will divide both sides by -3, and that will give us y. So we have the times -3, the divide by -3, they cancel, and so we have y is equal to -5. 15 divided by -3 is -5. So the y-intercept would be the point 0 for x, -5 for y. The y-intercept is always 0, something. It always has a 0 for the x. All right. And so actually, let's continue with that idea using the intercepts. And let's graph this linear equation y equals 2x plus 3. Now, as soon as you have 2 points, you've defined a line. Any 2 points, you can just draw a line through them and there's your graph. So what we need is to graph this equation. We need 2 points. And remember, a point is a solution. So let's find 2 solutions of the equation y equals 2x plus 3. Now the way to get solutions is to, you could plug in a number for one of the letters and figure out what the other one has to be. So let's do a little t-chart here. So x and y. So let's find the y-intercept. So what happens when x is equal to 0? So we get y equals 2 times 0 plus 3. And 2 times 0 is 0, so we get y is equal to 3. All right, so there's 1 point. 0 for when x is 0, the y has to be 3. So 0 for the x, 1, 2, 3 for the y. And now let's do the same thing, but find the x-intercept. So we'll plug in a 0 for the y. Okay, so 0, instead of y equals, so this is a separate equation. So y equals 2x plus 3, we'll plug in a 0 for the y. So 0 equals 2x plus 3. And now we have to solve for x. So we could subtract 3 from both sides. So we get negative 3 on the left. These 3's cancel. And we get 2x on the right. And then we can divide both sides by 2. So that will give us x on the right-hand side and negative 3 divided by 2 on the left. So when y is equal to 0, and we solve for x, we get x is equal to negative 3 over 2, or that's about negative 1.5. So here's negative 1 on the x-axis. Here's negative 2 on the x-axis. Let's make this line a different color. Let's go with red. So negative 3 halves, negative 3 over 2, or negative 1.5 would be right here between the negative 1 and the negative 2. All right, and our line, we just draw a line through those 2 points. And you can use any 2 points. It doesn't have to be these two, but 0 is an easy number to work with because 0 times anything is 0. All right, one more on this worksheet before we move on to the next video. So here we have a word problem. The value given by V in dollars of a cell phone is given by V equals negative 75 times T plus 650, where T is the number of years since the phone was first purchased. After how many years is the value of the phone $50? All right, so let's first look at this equation. The value equals negative 75 times the number of years plus 650. Well, what does this mean? This negative 75 times the number of years, well, if the phone is 1 year old, you would plug in a 1 for T, and you would have negative 75 times 1. Well, that negative 75 means the phone is decreasing in value by $75 a year. So after 2 years, you would plug in 2 for T. So it would drop negative 75 twice. It would drop by $75 twice. All right, so what we want is, after how many years is the value of the phone $50? So we're given that V is equal to 50, and we have to solve for T. We're looking for, so this is after how many years? We're looking for number of years. Okay, so we'll plug in 50 for V. We're given, remember, the variables are just a temporary placeholder. In this case, we plug in 50 for the V. So 50 is equal to negative 75 times T plus 650. This is very similar to problems we've done in chapter 8. All right, so we'll solve for t. So let's get rid of the 650. Subtract 650 from both sides. So the positive, the negative cancel. And on the right-hand side, we're left with negative 75t. And on the left, we have a positive 50 minus a 650 will give us negative 600. And the last thing to do to solve for t, let's divide both sides. Oop, not negative 5, negative 75. Divide both sides by negative 75. On the right, the 75s cancel. We have t. And if we do 600 divided by 75, we will get positive 8. So we would say after 8 years, the value of the phone has dropped to $50. All right, that does it for finishing up this worksheet. I hope this was helpful.